Okay, this is Algebra 2, Set 61, Chemical Mixture Problems, Part B. So we'll start with problem. You have water evaporated from 100 gallon, how much water should be evaporated from 100 gallons of 10% brine solution to get a 40% brine solution? So there are two ways to look at it. You can look at it using salt or using water. So we know that salt does not evaporate, so when you're doing the problem, you have to keep that in mind. When you're evaporating, salt does not evaporate, but water does evaporate. Okay, so if you're doing a salt problem, you have a value that you start with, a certain number of gallons of water that you start with, or brine solution. You're going to take out no salt, and then you'll be left with a certain amount of brine solution. What you're taking out is water. So when we come over to the water solution, or the water equation, you have what you start with, and then you're going to take out water, and then you'll be left with what you start with. So that's kind of what you have to remember when you're doing these problems. And it depends on the percentage of the salt or the water. So we'll start this problem. So what we start with is we have a number equation and we have a value equation, just like those coin problems. So we'll start with salt. We start with 100 gallons. We're going to subtract a certain amount of saline solution out, and then what we're left with is whatever that 100 minus x is. When we add in the percentages, we're talking about salt. So we started with a 10% brine solution. Now remember, salt does not evaporate, so the percentage of salt that's going away is 0. And then we want to be left with 40%. Okay, now we're going to talk about water. If we're going to set up the water equation, it starts out the same way. You start out with 100 gallons. You're going to take a certain amount of the brine away, and then what you're left with is 100 minus x. Now, the water piece is a little bit different. If you add 10% salt, that means you're going to have 90% water. And when we evaporate, no salt evaporates, but all the water evaporates. So we're going to be evaporating 100% of the water, or in other words, 1x. And then we're left with, before we had a 40% salt content, so now we're going to have a 60% water content. So those are your two possibilities for equations. So we'll go back. We'll start with the brine solution, the salt solution. 0.10 times 100 is 10, and that's going to be equal to 40 minus 0.4x. We solve that, subtract 40 from both sides, we get negative 30 equals 0.4x, negative 0.4x, divide by negative 0.4, and we get x is equal to 75. And so that's our solution. We can do it using the water, and we just go ahead and solve that. 0.9 times 100 is 90, minus x equals 60, minus 0.6x. We'll subtract 60 and add 1 to negative 0.6, divide by 0.4, and we get the same answer. Okay, let's try another example. This one has to do with milk and butter fat. So we need to know if we start with 900 pounds of milk that are 2% butter fat, how much butter fat do we need to add to make it be 8% butter fat? So we're going to need a number equation and a value equation. We're going to start with 900 pounds of milk. We're going to add a certain amount of butter fat, and what we end up with is the sum of 900 and the butter fat. So we know that we started with 2%, and when we add butter fat, it's 100% butter fat that we're adding. So we're just adding 1 X, which is 100% of the butter fat, and we need to end up with 8% at the end. So let's go ahead and just multiply this out. 0.02 times 900 is 18 plus X equals 72 plus 0.08X, and then we'll solve both sides. 1X minus 0.08X is 0.92X. 72 minus 18 is 54. Divide both sides by 0.92. You get 58.7 pounds. Okay, let's do one more problem. If you have 100 kilograms of 20% glycol solution, how much of a 40% solution should they add to get 35% glycol? So this one's going to be just a little bit different because we're not dealing with adding pure butter fat, and we're not dealing with evaporating all the water. We've got a percentage of a solution. So we start with our two equations, the number and the value. We're going to start with 100 kilograms. We're going to add some more solution, and we'll end up with 100 plus X. And then what we started with was 20% glycol, and then we're going to have 40% of X, and then 35% of the end product. So now we just simplify. 0.2 times 100 is 20. 0.4 times X is 0.4X. 0.35 times 100 is 35. And 0.35X. So now we just need to simplify. 0.4 minus 35 is 0.05X. 35 minus 20 is 15. Divide both sides by 0.05 and we get X is 300 kilograms. And that's your answer.